here's the indexes from 0, 1, 2, 3, 4, 5. And so here 0, 0, 0.6, 1, 1, 0.49, 0, 2, 0.13, and so forth. So yeah, this works just as well with more than 2 columns. So we can add, for doing a full MNIST, so all the digits from 0 to 9, we could have 10 columns, and we would just be indexing into the 10. So this thing we're doing, where we're going minus our activations matrix, all of the numbers from 0 to n, and then our targets, is exactly the same as something that already exists in PyTorch called f.nll-loss, as you can see. Exactly the same. Right, so again, we're kind of seeing that these things inside PyTorch and FastAI are just little shortcuts for stuff we can write ourselves. NLL-loss stands for negative log likelihood. Again, sounds complex, but actually it's just this indexing expression. Rather confusingly, there's no log in it. We'll see why in a moment. So let's talk about logs. So this loss function works quite well, as we saw in the Notebook 04. It's basically this. It is exactly the same as we saw in Notebook 04, just a different way of expressing it. But we can actually make it better, because remember, the probabilities we're looking at are between 0 and 1. So they can't be smaller than 0. They can't be greater than 1. Which means that if our model is trying to decide whether to predict 0.99 or 0.999, it's going to think that those numbers are very, very close together, so it won't really care. But actually, if you think about the error, if there's like 1,000 things, then this would like be 10 things are wrong, and this would be like 1 thing is wrong. So this is really like 10 times better than this. So really what we'd like to do is to transform the numbers between 0 and 1 to instead be between negative infinity and infinity. And there's a function that does exactly that, which is called logarithm. Okay, so the numbers we could have can be between 0 and 1. And as we get closer and closer to 0, it goes down to infinity, and then at 1, it's going to be 0. And we can't go above 0 because our loss function, we want to be negative. So this logarithm, in case you forgot, hopefully you vaguely remember what logarithm is from high school, but basically the definition is this. If you have some number that is y that is b to the power of a, then logarithm is defined such that a equals the logarithm of y comma b. In other words, it tells you b to the power of what equals y, which is not that interesting of itself, but one of the really interesting things about logarithms is this very cool relationship, which is that log of a times b equals log of a plus log of b. And we use that all the time in deep learning and machine learning, because this number here, a times b, can get very, very big or very, very small. If you multiply things, a lot of small things together, you'll get a tiny number. If you multiply a lot of big things together, you'll get a huge number. It can get so big or so small that the kind of the precision in your computer's floating point gets really bad. Whereas this thing here, adding, is not going to get out of control. So we really love using logarithms, like particularly in a deep neural net where there's lots of layers. We're kind of multiplying and adding many times. So this kind of tends to come out quite nicely. So when we take the probabilities that we saw before, the things that came out of this function, and we take their logs, and we take the mean, that is called negative log likelihood. And so this ends up being kind of a really nicely behaved number because of this property of the log that we described. So if you take the softmax and then take the log and then pass that to an LL loss, because remember that didn't actually take the log at all despite the name, that gives you cross entropy loss. So that leaves an obvious question of why doesn't NLL loss actually take the log? And the reason for that is that it's more convenient computationally to actually take the log back at the softmax step. So PyTorch has a function called log softmax. And so since it's actually easier to do the log at the softmax stage, it's just faster and more accurate, PyTorch assumes that you use soft logmax and then pass that to NLL loss. So NLL loss does not do the log. It assumes that you've done the log beforehand. So log softmax followed by NLL loss is the definition of cross entropy loss in PyTorch. So that's our loss function. And so you can pass that some activations and some targets and get back a number. And pretty much everything in PyTorch, every one of these kinds of functions, you can either use the NN version as a class, like this, and then call that object as if it's a function, or you can just use f dot with the camel case name as a function directly. And as you can see, they're exactly the same number. People normally use the class version. In the documentation in PyTorch, you'll see it normally uses the class version. So we'll tend to use the class version as well. You'll see that it's returning a single number, and that's because it takes the mean, because a loss needs to be, as we've discussed, the mean. But if you want to see the underlying numbers before taking the mean, you can just pass in reduction equals none, and that shows you the individual cross entropy losses before taking the mean. Okay. Great. So this is a good place to stop with our discussion of loss functions and such things. Rachel, were there any questions about this?
Why does the loss function need to be negative?
Well, I mean, I guess it doesn't, but it's we want something that the lower it is, the better. And we kind of need it to cut off somewhere. I have to think about this more during the week because I'm a bit tired. Yeah, so let me refresh my memory when I'm awake. Okay, now next week, well, note not for the video. Next week actually happened last week, so the thing I'm about to say is actually referring to. So next week we're going to be talking about data ethics. And I wanted to kind of segue into that by talking about how my week's gone. Because a week or two ago, I did as part of a lesson, I actually talked about the efficacy of masks, and specifically wearing masks in public. And I pointed out that the efficacy of masks seemed like it could be really high, and maybe everybody should be wearing them. And somehow I found myself as the face of a global advocacy campaign. And so if you go to masksforall.co, you will find a website talking about masks. And I've been on TV shows in South Africa and the US and England and Australia and on radio and blah, 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 talking about masks. Why is this? Well, it's because as a data scientist, I noticed that the data around masks seemed to be getting misunderstood. And it seemed that that misunderstanding was costing possibly hundreds of thousands of lives. Literally in the places that were using masks, it seemed to be associated with, orders of magnitude fewer deaths. And one of the things we'll talk about next week is like, what's your role as a data scientist? And I strongly believe that it's to understand the data and then do something about it. And so nobody was talking about this. So I ended up writing an article that appeared in the Washington Post that basically called on people to really consider wearing masks, which is this article. And I was lucky. I managed to kind of get a huge team of brilliant, not huge, a pretty decent sized team of brilliant volunteers who helped, kind of build this website and kind of some PR folks and stuff like that. But what became clear was, I was talking to politicians, senators, staffers, and what was becoming clear is that people weren't convinced by the science, which is fair enough because it's hard to, when the WHO and the CDC are saying you don't need to wear a mask, and some random data scientist is saying that doesn't seem to be what the data is showing, if you've got half a brain, you would pick the WHO and the CDC, not the random data scientist. So I really felt like if I was going to be an effective advocate, I needed to sort the science out. And it, credentialism is strong. And so it wouldn't be enough for me to say it. I needed to find other people to say it. So I put together a team of 19 scientists, including, a professor of sociology, a professor of aerosol dynamics, the founder of an African movement that kind of studied preventative methods for tuberculosis, a Stanford professor who studies mask disposal and cleaning methods, a bunch of Chinese scientists who study epidemiology modeling, a UCLA professor who is one of the top infectious disease epidemiologist experts, and so forth. So like this kind of all-star team of people from all around the world. And I'd never met any of these people before. So, well, no, not quite true. I knew Austin a little bit, and I knew Zeynep a little bit. I knew Lex a little bit. But on the whole, and well, Reshma, we all know she's awesome. So it was great to actually have a fast AI community person there too. And so, but yeah, I kind of tried to pull together people from, as many geographies as possible and as many areas of expertise as possible. And, the kind of the global community helped me find papers about everything, about, how different materials work, about how droplets form, about epidemiology, about case studies of people infecting with and without masks, blah, blah, blah. And we ended up in the last week, basically, we wrote this paper. It contains 84 citations. We basically worked around the clock on it as a team. And it's out. And it's been sent to a number of, some of the earlier versions 3 or 4 days ago, we sent to some governments. So one of the things is in this team, I try to look for people who were, working closely with government leaders, not just that they're scientists. And so this went out to a number of government ministers. And in the last few days, I've heard that it was a very significant part of decisions by governments to change their guidelines around masks. And the fight's not over by any means. In particular, the UK is a bit of a holdout. But I'm going to be on ITV tomorrow and then BBC the next day. It's kind of required stepping out to be a lot more than just a data scientist. I've had to pull together, politicians and staffers. I've had to, hustle with the media to try and get, coverage. And, today I'm now starting to do a lot of work with unions to try to get unions to understand this. It's really a case of like saying, okay, as a data scientist and in conjunction with real scientists, we've built this really strong understanding that masks, are this simple but incredibly powerful tool that doesn't do anything unless I can effectively communicate this to decision makers. So today I was, on the phone to, one of the top union leaders in the country, explaining what this means. Basically, it turns out that in buses in America, the air conditioning is set up so that it blows from the back to the front. And there's actually case studies in the medical literature of how people that are seated kind of downwind of an air conditioning unit in a restaurant ended up all getting sick with COVID-19. And so we can see why bus drivers are dying because they're right in the wrong spot here and their passengers aren't wearing masks. So I kind of trying to explain this science to union leaders so that they understand that to keep the workers safe, it's not enough just for the driver to wear a mask, but all the people on the bus needed to be wearing masks as well. So, all of this is basically to say, as data scientists, I think we have a responsibility to study the data and then do something about it. It's not just a research, exercise. It's not just a computation exercise. What's the point of doing things if it doesn't lead to anything? Next week we'll be talking about this a lot more, but I think, this is a really, to me, kind of interesting example of how digging into the data can lead to really amazing things happening. And in this case, I strongly believe, and a lot of people are telling me they strongly believe, that this kind of advocacy work that's come out of this data analysis is already saving lives. And so I hope this might help inspire you to take your data analysis and to take it to places that it really makes a difference. So thank you very much, and I'll see you next week.
Welcome to Lesson 5, and we'll be talking about ethics for data science, and this corresponds to Chapter 3 of the book. I've also just taught a 6-week version of this course. I'm currently teaching an 8-week version of this course, and we'll release some combination or subset of that as a FastAI and USF Ethics for Data Science class if you want more detail coming in July. I am Rachel Thomas. I am the founding director of the Center for Applied Data Ethics at the University of San Francisco and also co-founder of FastAI together with Jeremy Howard. My background, I have a PhD in math and worked as a data scientist and software engineer in the tech industry, and then have been working at USF and on FastAI for the past 4 years now. So ethics issues are in the news. These articles, I think, are all from this fall, kind of showing up at this intersection of how technology is impacting our world in many kind of increasingly powerful ways, many of which really raise concerns. And I want to start by talking about 3 cases that I hope everyone working in technology knows about and is on the lookout for. So even if you only watch 5 minutes of this video, these are kind of the three cases I want you to see. And one is feedback loops. And so feedback loops can occur whenever your model is controlling the next round of data you get. So the data that's returned quickly becomes flawed by the software itself. And this can show up in many places. One example is with recommendation systems. And so recommendation systems are ostensibly about predicting what content the user will like, but they're also determining what content the user is even exposed to and helping determine what has a chance of becoming popular. And so YouTube has gotten a lot of attention about this for kind of highly recommending many conspiracy theories, many kind of very damaging conspiracy theories. There was also, they've kind of put together recommendations of pedophilia, picked out of what were kind of innocent home movies, but when are kind of strung together, ones that happen to have young girls in bathing suits or in their pajamas. So there's some really concerning results, and this is not something that anybody intended, and we'll talk about this more later. I think particularly for many of us coming from a science background, we're often used to thinking of like, oh, like we observe the data, but really whenever you're building products that interact with the real world, you're also kind of controlling what the data looks like. Second case study I want everyone to know about comes from software that's used to determine poor people's health benefits. It's used in over half of the 50 states. And The Verge did an investigation on what happened when it was rolled out in Arkansas. And what happened is there was a bug in the software implementation that incorrectly cut coverage for people with cerebral palsy or diabetes. Including Tammy Dobbs, who's pictured here and was interviewed in the article. And so these are people that really needed this health care, and it was erroneously cut due to this bug. And so they were really, and they couldn't get any sort of explanation, and there was no appeals or recourse process in place. And eventually this all came out through a lengthy court case, but it's something where it caused a lot of suffering in the meantime. And so it's really important to implement systems with a way to identify and address mistakes, and to do that quickly and in a way that hopefully minimizes damage, because we all know software can have bugs, our code can behave in unexpected ways, and we need to be prepared for that. I wrote more about this idea in a post 2 years ago, What HBR Gets Wrong About Algorithms and Bias. And then third case study that everyone should know about. So this is LaTanya Sweeney, who's director of the Data Privacy Lab at Harvard. She has a PhD in computer science. And she noticed several years ago that when you Google her name, you would get these ads saying LaTanya Sweeney arrested, implying that she has a criminal record. She's the only LaTanya Sweeney, and she has never been arrested. She paid $50 to the background check company and confirmed that she's never been arrested. She tried Googling some other names, and she noticed, for example, Kristen Lindquist got much more neutral ads that just say, we found Kristen Lindquist, even though Kristen Lindquist has been arrested 3 times. And so being a computer scientist, Dr. Sweeney studied this very systematically. She looked at over 2,000 names and found that this pattern held, in which disproportionately African-American names were getting these ads suggesting that the person had a criminal record, regardless of whether they did, and traditionally European-American or white names were getting more neutral ads. And this problem of kind of bias in advertising shows up a ton. Advertising is kind of the profit model for most of the major tech platforms. And it kind of continues to pop up in high impact ways. Just last year, there was research showing how Facebook's ad system discriminates even when the person placing the ad is not trying to do so. So for instance, the same housing ad, exact same text, if you change the photo between a white family and a black family, it gets served to very different audiences. And so this is something that can really impact people when they're looking for housing, when they're applying for jobs, and is a definite area of concern. So now I want to kind of step back and ask why does this matter? And so a very kind of extreme example is just that data collection has played a pivotal role in several genocides, including the Holocaust. And so this is a photo of Adolf Hitler meeting with the CEO of IBM at the time. I think this photo was taken in 1937. And IBM continued to partner with the Nazis kind of long past when many other companies broke their ties. They produced computers that were used in concentration camps to code whether people were Jewish, how they were executed. And this is also different from now, where you might sell somebody a computer and then never hear from them again. These machines require a lot of maintenance and kind of ongoing relationship with vendors to kind of upkeep and repair them. It's something that a Swiss judge ruled. It does not thus seem unreasonable to deduce that IBM's technical assistance facilitated the task of the Nazis in the commission of their crimes against humanity. Acts also involving accountancy and classification by IBM machines and utilized in the concentration camps themselves.
I'm told that they haven't gotten around to apologizing yet.
Oh, that's...
I guess they've been busy.
Terrible too, yeah. Okay. Yeah, and so this is a very kind of a very sobering example, but I think it's important to keep in mind kind of what can go wrong and how technology can be used for harm, for very, very terrible harm. And so this just kind of raises questions that we all need to grapple with of how would you feel if you discovered that you had been part of a system that ended up hurting society? Would you even know? Would you be open to finding out kind of how things you had built may have been harmful? And how can you help make sure this doesn't happen? And so I think these are questions that we all need to grapple with. It's also important to think about unintended consequences, how your tech could be used or misused, whether that's by harassers, by authoritarian governments, for propaganda or disinformation. And then on a kind of a more concrete level, you could even end up in jail. And so there was a Volkswagen engineer who got prison time for his role in the diesel cheating case. So if you remember, this is where Volkswagen was cheating on emissions test, and one of the kind of programmers that was a part of that. And that person was just following orders from what their boss told them to do. But that is not a good excuse for doing something that's unethical, and so something to be aware of. So ethics is the discipline dealing with what's good and bad. It's a set of moral principles. It's not a set of answers, but it's kind of learning what sort of questions to ask and even how to weigh these decisions. And I'll say some more about kind of ethical foundations and different ethical philosophies later on in this lesson. But first, I'm going to kind of start with some use cases. Ethics is not the same as religion, laws, social norms, or feelings, although it does have overlap with all these things. It's not a fixed set of rules. It's well-founded standards of right and wrong. And this is something where clearly not everybody agrees on the ethical action in every case, but that doesn't mean that kind of anything goes or that all actions are considered equally ethical. There are many things that are widely agreed upon, and there are kind of philosophical underpinnings for kind of making these decisions. And ethics is also the ongoing study and development of our ethical standards. It's a kind of never-ending process of learning to kind of practice our ethical wisdom. And I'm going to refer several times to, so here I'm referring to a few articles from the Markula Center for Tech Ethics at Santa Clara University. In particular, the work of Shannon Valor, Brian Green, and Irina Reiku is fantastic, and they have a lot of resources, some of which I'll circle back to later in this talk.
I spent years of my life studying ethics. It was my major at university, and so much time on the question of what is ethics. I think my takeaway from that is studying the philosophy of ethics was not particularly helpful in learning about ethics.
Yes, and I will try to keep this kind of very applied and very practical, also very kind of tech industry specific of what do you need in terms of applied ethics. And
yeah, Markula said it's great. They take stuff that I thought was super dry and turn it into useful checklists and things.
I did want to note, this was really neat. So Casey Fiesler is a professor at University of Colorado that I really admire, and she created a crowdsourced spreadsheet of tech ethics syllabi. This was maybe 2 years ago, and got over 200 syllabi entered into this crowdsourced spreadsheet. And then she did a meta-analysis on them of kind of looking at all sorts of aspects of the syllabi and what's being taught and how it's being taught. And published a paper on it. What do we teach when we teach tech ethics? And a few interesting things about it is there are a lot of ongoing discussions and lack of agreement on how to best teach tech ethics. Should it be a standalone course versus worked into every course in the curriculum? Who should teach it? A computer scientist, a philosopher, or a sociologist? And she analyzed for the syllabi what was the course home and the instructor home, and you can see that the instructors came from a range of courses, including a range of disciplines: computer science, information science, philosophy, science and tech studies, engineering, law, math, business. What topics to cover? A huge range of topics that can be covered, including law and policy, privacy and surveillance, inequality, justice and human rights, environmental impact, AI and robots, professional ethics, work and labor, cybersecurity. The list goes on. And so this is clearly more than can be covered in even a full semester length course, and certainly not in kind of a single lecture. What learning outcomes? This is an area where there's a little bit more agreement, where kind of the number one skill that courses were trying to teach was critique, followed by spotting issues, making arguments. So a lot of this is just even learning to spot what the issues are and how to critically evaluate kind of a piece of technology or a design proposal to see what could go wrong and what the risk could be. All right, so we're going to go through kind of a few different core topics, and as I suggested, this is just going to be a kind of extreme subset of what could be covered. We've tried to pick things that we think are very important and high impact. So one is recourse and accountability. So I already shared this example earlier of the system that's determining poor people's healthcare benefits, having a bug. And something that was kind of terrible about this is nobody took responsibility, even once the bug was found. So the creator of the algorithm was interviewed and asked, they asked him, should people be able to get an explanation for why their benefits have been cut? And he gave this very callous answer of, yeah, they probably should, but I should probably dust under my bed, like who's going to do that, which is very callous. And then he ended up blaming the policymakers for how they had rolled out the algorithm. The policymakers, could blame the software engineers that implemented it. And so there was a lot of passing the buck here. Dana Boyd has said that, it's always been a challenge for bureaucracy to assign responsibility, or bureaucracy is used to evade responsibility. And today's algorithmic systems are often extending bureaucracy.
A couple of questions and comments about cultural context.
Yeah.
Nalini notes that there didn't seem to be any mention of cultural contexts for ethics as part of those syllabi, and somebody else was asking, how do you deal, is this culturally dependent, and how do you deal with that?
It is culturally dependent. I will mention this briefly later on. So I'm going to share 3 different ethical philosophies that are kind of from the West. And we'll talk just briefly of one slide on, for instance, right now there are a number of indigenous data sovereignty movements. And I know the Maori data sovereignty movement has been particularly active. But different cultures do have different views on ethics. And I think that the cultural context is incredibly important. And we will not get into it tonight, but there's also kind of a growing field of algorithmic colonialism and kind of studying what are some of the issues when you have technologies built in one, particular country and culture being implemented, halfway across the world in very different cultural context, often with little to no input from people living in that culture. And although I do want to say that there are things that are widely, although not universally, agreed on. And so, for instance, the Universal Declaration on Human Rights, despite the name, it is not universally accepted, but many, many different countries have accepted that as a human rights framework and as those being fundamental rights. And so there are kind of principles that are often held cross-culturally, although, yeah, it's rare for something probably to be truly, truly universal. So returning to this topic of kind of accountability and recourse, something to keep in mind is that data contains errors. So there was a database used in California that's tracking supposedly gang members, and an auditor found that there were 42 babies under the age of 1 who had been entered into this database. And something concerning about the database is that it's basically never updated. I mean, people are added, but they're not removed. And so once you're in there, you're in there. And 28 of those babies were marked as having admitted to being gang members. And so keep in mind that this is just a really obvious example of the error, but how many other kind of totally wrong entries are there? Another example of data containing errors involves the 3 credit bureaus in the United States. The FTC's large-scale study of credit reports found that 26% had at least one mistake in their files, and 5% had errors that could be devastating. This is the headline of an article that was written by a public radio reporter who went to get an apartment, and the landlord called him back afterwards and said, you know, your background check showed up that you had firearms convictions. And this person did not have any firearms convictions. And it's something where in most cases, the landlord would probably not even tell you and let you know that's why you weren't getting the apartment. And so this guy looked into it. I should note that this guy was white, which I'm sure helped him in getting the benefit of the doubt, and found this error. And he made dozens of calls and could not get it fixed until he told them that he was a reporter and that he was going to be writing about it, which is something that most of us would not be able to do. But it was even once he had pinpointed the error and he had to, you know, talk to the, you know, like county clerk in the place he used to live, it was still a very difficult process to get it updated. And this can have a huge, huge impact on people's lives. There's also the issue of when technology is used in ways that the creators may not have intended. So for instance, with facial recognition, it is pretty much entirely being developed for adults, yet NYPD is putting the photos of children as young as age 11 into databases, and we know the error rates are higher. This is not how it was developed. So this is a serious concern. And there are a number of kind of misuses. The Georgetown Center for Privacy and Technology, which is fantastic, you should definitely be following them, did a report, Garbage In, Garbage Out, looking at how police were using facial recognition in practice. And they found some really concerning examples. For instance, in one case, NYPD had a photo of a suspect, and it wasn't returning any matches. And they said, well, this person kind of looks like Woody Harrelson. So then they Googled the actor Woody Harrelson and put his face into the facial recognition and used that to generate leads. And this is clearly not the correct use at all, but it's a way that it's being used. And so there's kind of total lack of accountability here. And then another kind of study of cases in all 50 states of police officers kind of abusing confidential databases to look up ex-romantic partners or to look up activists. And so, you know, here this is not necessarily an error in the data, although that can be present as well, but kind of keeping in mind how it can be misused by the users. All right, so next topic is feedback loops and metrics. And so I talked a bit about feedback loops in the beginning as kind of one of the 3 key use cases. And so this is a topic I wrote a blog post about this fall. The problem with metrics is a big problem for AI. And then together with David Uminsky, who's director of the Data Institute, expanded this into a paper, Reliance on Metrics is a Fundamental Challenge for AI. And this was accepted to the Ethics and Data Science Conference. But overemphasizing metrics can lead to a number of problems, including manipulation, gaming, myopic focus on short-term goals because it's easier to track short-term quantities, unexpected negative consequences, and much of AI and machine learning centers on optimizing a metric. This is kind of both, the strength of machine learning is it's gotten really, really good at optimizing metrics, but I think this is also kind of inherently a weakness or a limitation. I'm going to give a few examples, and this can happen even not just in machine learning, but in analog examples as well. So this is from a study of when England's public health system implemented a lot more targets around numbers in the early 2000s. And the study was called What's Measured is What Matters. And so they found, one of the targets was around reducing ER wait times, which seems like a good goal. However, this led to canceling scheduled operations to draft extra staff into the ER. So if they felt like there were too many people in the ER, they would just start canceling operations so they could get more doctors. Requiring patients to wait in queues of ambulances because time waiting in an ambulance didn't count towards your ER wait time. Turning stretchers into beds by putting them in hallways. And there were also big discrepancies in the numbers reported by hospitals versus by patients. And so if you ask the hospital on average, how long are people waiting, you get a very different answer than when you were asking the patients, how long did you have to wait? Another example is essay grading software. And so this essay grading software, I believe, is being used in 22 states now in the United States. Yes, 22 states, and it tends to focus on metrics like sentence length, vocabulary, spelling, subject-verb agreement, because these are the things that we know how to measure and how to measure with a computer. But it can't evaluate things like creativity or novelty. However, gibberish essays with lots of sophisticated words score well, and there are even examples of people creating computer programs to generate these kind of gibberish sophisticated essays, and then they're graded by this other computer program and highly rated. There's also bias in this. Essays by African American students received lower grades from the computer than from expert human graders. And essays by students from mainland China received higher scores from the computer than from expert human graders. And the authors of this study thought that this result suggests they may be using chunks of pre-memorized text that score well. And these are just kind of two examples. I have a bunch more in the blog post and even more in the paper of ways that metrics can invite manipulation and gaming whenever they're given a lot of emphasis. And this is a Goodhart's laws, kind of a law that a lot of people talk about, and it's this idea that the more you rely on a metric, the less reliable it becomes. So returning to this example of feedback loops and recommendation systems, Guillaume Chaslot is a former Google/YouTube engineer. YouTube is owned by Google. And he wrote a really great post, and he's done a ton to raise awareness about this issue and founded the nonprofit Algo Transparency, which kind of externally tries to monitor YouTube's recommendations. He's partnered with The Guardian and The Wall Street Journal to do investigations. But he wrote a post around how kind of in the earlier days, the recommendation system was designed to maximize watch time. And so, and this is something else that's often going on with metrics, is that any metric is just a proxy for what you truly care about. And so here, the team at Google was saying, well, if you're watching more YouTube, it signals to us that they're happier. However, this also ends up incentivizing content that tells you the rest of the media is lying, because kind of believing that everybody else is lying will encourage you to spend more time on a particular platform. So Guillaume wrote a great post about this kind of mechanism that's at play. And, this is not just YouTube. This is any recommendation system could, I think, be susceptible to this. And there has been a lot of talk about issues with many recommendation systems across platforms. But it is something to be mindful of, and something that the kind of creators of this did not anticipate. Then last year, Guillaume kind of gathered this data on, so here the x-axis is the number of channels, number of YouTube channels recommending a video, and the y-axis is the log of the views. And we see this extreme outlier, which was Russia Today's take on the Mueller report. And this is something that Guillaume observed and then was picked up by the Washington Post. But this strongly suggests that Russia Today has perhaps gamed the recommendation algorithm, which is not surprising, and it's something that I think many content creators are conscious of and trying to experiment and see what gets more heavily recommended and thus more views. So it's also important to note that our online environments are designed to be addictive. And so when kind of what we click on is often used as a proxy of what we enjoy or what we like, that's not necessarily though for of our kind of like our best selves or our higher selves. It's what we're clicking on in this kind of highly addictive environment that's often appealing to some of our kind of lower instincts. Zeynep Tufekci uses the analogy of a cafeteria that's kind of shoving salty, sugary, fatty foods in our faces, and then learning that, hey, people really like salty, sugary, fatty foods, which I think most of us do in a kind of very primal way. But we often, kind of our higher self is like, oh, I don't want to be eating junk food all the time. And online, we often kind of don't have great mechanisms to say, like, oh, I really want to read like more long form articles that took months to research and are going to take a long time to digest. While we may want to do that, our online environments are not always conducive to it. Yes?
Sylvain made a comment about the false sense of security argument, which is very relevant to masks and things. Did you have anything to say about this false sense of security argument?
Can you say more?
There's a common feedback at the moment that people shouldn't wear masks because it makes a false sense of security. That kind of makes sense to you from an ethical point of view to be telling people that?
No, I don't think that's a good argument at all. In general, there's so many, and other people, including Jeremy, have pointed this out. There's so many actions we take to make our lives safer, whether that's wearing seatbelts or wearing helmets when biking, practicing safe sex, like all sorts of things where we really want to maximize our safety. And so I think, and Zeynep Tufekci had a great thread on this today of, it's not that there can never be any sort of impact in which people have a false sense of security, but it is something that you would really want to be gathering data on and build a strong case around and not just assume it's going to happen. And that in most cases people can think of, even if that is a small second order effect, the effect of doing something that increases safety tends to have a much larger impact on actually increasing safety. Do you have anything to add to that, or? As I mentioned before, a lot of our incentives are focused on short-term metrics. Long-term things are much harder to measure and often involve kind of complex relationships. And then the fundamental business model of most of the tech companies is around manipulating people's behavior and monopolizing their time. And these things, I don't think in advertising is inherently bad, but I think it can be negative when taken to an extreme. There's a great essay by James Grimmelman, "The Platform is the Message," and he points out these platforms are structurally at war with themselves. The same characteristics that make outrageous and offensive content unacceptable are what make it go viral in the first place. And so there's this kind of real tension here in which often things, that kind of can make content really offensive or unacceptable to us are also what are kind of fueling their popularity and being promoted in many cases. And this is an interesting essay because he does this like really in-depth dive on the Tide Pod challenge, which was this meme around eating Tide Pods, which are poisonous. Do not eat them. And he really analyzes it though, and it's a great look at meme culture, which is very common, and how he kind of argues there's probably no example of someone talking about the Tide Pod challenge that isn't partially ironic, which is common in memes, that even kind of whatever you're saying, they're kind of layers of irony and different groups are interpreting them differently. And that even when you try to counteract them, you're still promoting them. So with the Tide Pod challenge, a lot of like celebrities were telling people don't eat Tide Pods, but that was also then kind of perpetuating the popularity of this meme. So this is an essay I would recommend that I think is pretty insightful. And so this is, we'll get to disinformation shortly, but the major tech platforms often incentivize and promote disinformation, and this is unintentional, but it is somewhat built into their design and architecture, their recommendation systems, and ultimately their business models. And then on the topic of metrics, I just want to bring up, so there's this idea of blitz scaling, and the premise is that if a company grows big enough and fast enough, profits will eventually follow. It prioritizes speed over efficiency and risks potentially disastrous defeat. And Tim O'Reilly wrote a really great article last year talking about many of the problems with this approach, which I would say is incredibly widespread and is, I would say, the kind of fundamental model underlying a lot of venture capital. And in it, though, investors kind of end up anointing winners as opposed to market forces. It tends to lend itself towards creating monopolies and duopolies. It's bad for founders, and people end up kind of spreading themselves too thin. So there are a number of significant downsides to this. Why am I bringing this up in an ethics lesson when we're talking about metrics? But hockey stick growth requires automation and a reliance on metrics. Also, prioritizing speed above all else doesn't leave time to reflect on ethics. And that is something that's hard, that I think you do often have to kind of pause to think about ethics. And that following this model, when you do have a problem, it's often going to show up on a huge scale if you've scaled very quickly. So I think this is something to at least be aware of.
So one person asks about, is there a dichotomy between AI ethics, which seems like a very first world problem, and wars, poverty, environmental exploitation as being a kind of different level of problem, I guess? And so there's an answer here, which somebody else maybe you can comment on whether you agree or have anything to add, which is that AI ethics, they're saying, is very important also for other parts of the world, particularly in areas with high cell phone usage. For example, many countries in Africa have high cell penetration. People get their news from Facebook and WhatsApp and YouTube, and though it's useful, it's been the source of many problems. Did you have any comments on kind of...
Yeah, so I think the first question, so AI ethics, as I noted earlier, and I'm using the phrase data ethics here, but it's this very broad and it refers to a lot of things. I think if people are talking about in the future, can computers achieve sentience, and what are the ethics around that? And that is not my focus at all. I'm very much focused on, and this is our mission with the Center for Applied Data Ethics at the University of San Francisco, is kind of how are people being harmed now? What are the most immediate harms? And so in that sense, I don't think that data ethics has to be a first world or kind of futuristic issue. It's what's happening now. And as the person said, in a few examples, one example I'll get to later is definitely the genocide in Myanmar, in which the Muslim minority, the Rohingya, are experiencing genocide. The UN has ruled that Facebook played a determining role in that, which is really intense and terrible. And so I think that's an example of technology, leading to very real harm now. There are also, WhatsApp, which is owned by Facebook. There have been issues with people spreading disinformation and rumors, and it's led to several lynching. dozens of lynchings in India of people kind of spreading these false rumors of, oh, there's a kidnapper coming around and in these kind of small remote villages, and then a visitor or stranger shows up and gets killed. WhatsApp also played a very important role, or bad role, in the election of Bolsonaro in Brazil, election of Duterte in the Philippines. So I think technology is having a kind of very immediate impact on people, and that those are the types of ethical questions I'm really interested in, and that I hope you are interested in as well. Do you have anything else to say about that, or? And I will talk about disinformation. I realize those were kind of some disinformation focus, and I'm going to talk about bias first. I think it's bias, then disinformation. Yes?
Question. When we talk about ethics, how much of this is intentional unethical behavior? I see a lot of the examples as more of incompetent behavior or bad modeling, where the product or models are rushed without sufficient testing, thought around bias, so forth, but not necessarily malintent.
Yeah, no, I agree with that. I think that most of this is unintentional. I do think there's often, though, well, we'll get into some cases. I think that in many cases the profit incentives are misaligned, and I do think that when people are earning a lot of money, it is very hard to consider actions that would reduce their profits, even if they would prevent harm and increase kind of ethics. And so I think that there's at some point where valuing profit over how people are being harmed is. When does that become intentional is a question to debate. But I don't think people are setting out to say, like, I want to cause a genocide or I want to help a authoritarian leader get elected. Most people are not starting with that, but I think sometimes it's a carelessness and a thoughtlessness. But that I do think we are responsible for that, and we're responsible to kind of be more careful and more thoughtful in how we approach things. All right, so bias. Bias, I think, is an issue that's probably gotten a lot of attention, which is great. And I want to get a little bit more in depth, because sometimes discussions on bias stay a bit superficial. There was a great paper by Harini Suresh and John Gutag last year that kind of came up with this taxonomy of different types of bias, and how they had kind of different sources in the machine learning kind of pipeline. And it was really helpful because different sources have different causes, and they also require different approaches for addressing them. Harini wrote a blog post version of the paper as well, which I love when researchers do that. I hope more of you, if you're writing an academic paper, also write the blog post version. And I'm just going to go through a few of these types. So one is representation bias. And so I would imagine many of you have heard of Joy Balamwini's work, which has rightly received a lot of publicity in Gender Shades. She and Timnit Gebru investigated commercial computer vision products from Microsoft, IBM, and Face++. And then Joy Balamwini and Deb Raji did a follow-up study that looked at Amazon and Keros and several other companies. And the typical results they kind of found basically everywhere was that these products performed significantly worse on dark-skinned women. So they were kind of doing worse on people with darker skin compared to lighter skin, worse on women than on men. And then the intersection of that, dark-skinned women had these very high error rates. And so one example is IBM. Their product was 99.7% accurate on light-skinned men and only 65% accurate on dark-skinned women. And again, this is a commercial computer vision product that was released. Question?
There's a question from the Trimmel study group about the Volkswagen example. In many cases, it's management that drives and rewards unethical behavior. What can an individual engineer do in a case like this, especially in a place like Silicon Valley where people move companies so often?
Yeah, so I think that's a great point. Yeah, and that is an example where I would have much rather seen people that were higher ranking doing jail time about this, because I think that they were driving that. I think that, yeah, it's great to remember that I know many people in the world don't have this option, but I think for many of us working in tech, particularly in Silicon Valley, we tend to have a lot of options, and often more options than we realize. Like, I talk to people frequently that feel trapped in their jobs, even though they're a software engineer in Silicon Valley, and so many companies are hiring. And so I think it is important to use that leverage. I think a lot of the kind of employee organizing movements are very promising, and that can be useful. But really trying to kind of vet the ethics of the company you're joining, and also being willing to walk away if you're able to do so. That's a great question. So with this example of representation bias, here the kind of way to address this is to build a more representative data set. It's very important to keep consent in mind of the people, if you're using pictures of people. But Joy Balamini and Timnit Gebru did this as part of Gender Shades. However, this is the fact that this was a problem not just for one company, but basically kind of every company they looked at, was due to this underlying problem, which is that in machine learning, benchmark data sets spur on a lot of research. However, kind of several years ago, all the kind of popular facial data sets were primarily of light-skinned men. For instance, IGBA, kind of popular face data set several years ago, only 4% of the images were of dark-skinned women. Yes?
Question. I've been worried about COVID-19 contact tracing and the erosion of privacy, location tracking, private surveillance companies, etc. What can we do to protect our digital rights post-COVID? Can we look to any examples in history of what to expect?
That is a huge question, and something I have been thinking about as well. I'm going to put that off till later to talk about, and that is something where in the course I teach, I have an entire unit on privacy and surveillance, which I do not in tonight's lecture, but I can share some materials. Although I am already really even just like rethinking how I'm going to teach privacy and surveillance in the age of COVID-19. Compared to 2 months ago when I taught it the first time. But that is something I think about a lot, and I will talk about later if we have time, or on the forums if we don't. But that's a great question, a very important question. On the topic, and I will say, and I have not had the time to look into them yet, I do know that there are groups that are working on what are kind of more privacy protecting approaches for tracking, and there are also groups putting out like if we are going to use some sort of tracking, what are the safeguards that need to be in place to do it responsibly? Yes?
I've been looking at that too. It does seem like this is a solvable problem with technology. Not all of these problems are, but you can certainly store a tracking history on somebody's cell phone. And then you could have something where you say when you've been infected, and at that point you could tell people that they've been infected by sharing the location in a privacy-preserving way. So I think some people are trying to work on that. I'm not sure it's particularly technically difficult problem. So I think sometimes there are ways to provide the minimum kind of level of, kind of application with whilst keeping privacy.
Yeah, and I think it is very important to also have things of, clear, like, expiration date. Like like looking back at 9/11 in the United States, that kind of ushered in all these laws that we're now kind of stuck with that have really eroded privacy of anything we do around COVID-19, being very clear, we are just doing this for COVID-19, and then there's a time limit and expires, and it's kind of for this clear purpose. And there are also issues, though, of, I mentioned earlier about data containing errors. I know this has already been an issue in some of other countries that we're doing kind of more surveillance-focused approaches of, what about like when it's wrong and people are getting kind of quarantined and they don't even know why and for no reason, and so to be mindful of those. But yeah, we'll talk more about this kind of later on. Back to bias. Yeah, we had kind of the benchmarks. So when the benchmark that's widely used has bias, then that is really kind of replicated at scale. And we're seeing this with ImageNet as well, which is probably the most widely studied computer vision data set out there. 2/3 of the ImageNet images are from the West. So this pie chart shows that the 45% of the images in ImageNet are from the United States, 7% from Great Britain, 6% from Italy, 3% from Canada, 3% from Australia. And we're covering a lot of this pie without having gotten to outside the West. And so then this has shown up in concrete ways of classifiers trained on ImageNet. So one of the categories is bridegroom, a man getting married. And there are a lot of cultural components to that, and so they have much higher error rates on bridegrooms from the Middle East or from the global South. And there are people now kind of working to diversify these data sets, but it is quite dangerous that they can really be kind of widely built on at scale, or have been widely built on at scale before these biases were recognized. Another case study is the Compass recidivism algorithm, which is used in determining who has to pay bail. So in the US, a very large number of people are in prison who have not even had a trial yet just because they're too poor to afford bail, as well as sentencing decisions and parole decisions. And ProPublica did a famous investigation in 2016 that I imagine many of you have heard of, in which they found that the false positive rate for Black defendants was nearly twice as high as for white defendants. So Black defendants who were a study from Dartmouth found that it was the software is no more accurate than Amazon Mechanical Turk workers, so random people on the internet. It's also, the software is, this proprietary black box using over 130 inputs, and it's no more accurate than a linear classifier on 3 variables. Yet it's still in use, and it's in use in many states. Wisconsin is one place where it was challenged, yet the Wisconsin Supreme Court upheld its use. If you're interested in the kind of topic of how you define fairness, because there is a lot of intricacy here, and I mean, I don't know anybody working on this who thinks that what Compass is doing is right, but they're using this different definition of fairness. Arvin Naranjan has a fantastic tutorial, 21 fairness definitions in their politics, that I highly recommend. And so going back to kind of this taxonomy of types of bias, this is an example of historical bias. And historical bias is a fundamental structural issue with the first step of the data generation process, and it can exist even given perfect sampling and feature selection. So kind of with the image classifier, that was something where we could go gather a more representative set of images, and that would help address it. That is not the case here. So gathering kind of more data on the U.S. criminal justice system, it's all going to be biased because that's really kind of baked into our history and our current state. And so this is, I think, good to recognize. One thing that can be done to try to at least mitigate this is to really talk to domain experts and by the people impacted. And so a really positive example of this is a tutorial from the Fairness, Accountability, and Transparency Conference that Christian Lum, who's the lead statistician for the Human Rights Data Analysis Group and now a professor at UPenn, organized together with a former public defender, Elizabeth Bender, who's the staff attorney for New York's Legal Aid Society, and Terrence Wilkerson, an innocent man who was arrested and could not afford bail. And Elizabeth and Terrence were able to provide a lot of insight to how the criminal justice system works in practice, which is often kind of very different from the more kind of clean, logical abstractions that computer scientists deal with. But it's really important to understand those kind of intricacies of how this is going to be implemented and used in these messy, complicated real-world systems. Question?
Aren't the AI biases transferred from real-life biases? For instance, colored people being treated differently is an everyday phenomenon. Women too.
That's correct, yes. So this is often, coming from real-world biases. And I'll come to this in a moment, but algorithmic systems can amplify those biases, so they can make them even worse. But they are often being learned from existing data.
I asked it because I guess I often see this being raised as if it's kind of a reason not to worry about AI. It's like, oh, it's not
Well,
AI.
I'm going to get to that in a moment. Actually, I think in 2 slides. So hold on to that question. I just want to talk about one other type of bias first, measurement bias. So this was an interesting paper by Sandil Mullainathan and Zayed Obermeyer, where they looked at historic electronic health record data to try to determine what factors are most predictive of stroke. And they said, this could be useful, like prioritizing patients at the ER. And so they found that the number one most predictive factor was prior stroke, which that makes sense. Second was cardiovascular disease. That seems reasonable. And then third most, kind of still very predictive factor, was accidental injury, followed by having a benign breast lump, a colonoscopy, or sinusitis. And so I'm not a medical doctor, but I can tell something weird's going on with factors 3 through 6 here. Like, why would these things be predictive of stroke? Does anyone want to think about why this might be? Any guesses you want to read?
No, I mean, there's lots of things.
Someone's, yeah.
Okay, the first answer was they test for it anytime someone has stroke. Confirmation bias, overfitting. Is it because they happen to be in hospital already? Biased data. EHR records these events. Because the data was taken before certain advances in medical science.
These are all good guesses. Not quite what I was looking for, but good thinking.
That's such a nice way of saying no.
So what the researchers say here is that this was about they're people that utilize healthcare a lot and people that don't, and they call it kind of high utility versus low utility of healthcare. And there are a lot of factors that go into this. I'm sure just who has health insurance and who can afford their copays. There may be cultural factors. There may be racial and gender bias. There is racial and gender bias on how people are treated. So a lot of factors, and basically people that utilize healthcare a lot, they will go to a doctor when they have sinusitis, and they will also go in when they're having a stroke. And people that do not utilize healthcare much are probably not going to go in possibly for either. And so what the authors write is that we haven't measured stroke, which is, a region of the brain being denied kind of new blood and new oxygen. What we've measured is who had symptoms, who went to the doctor, received tests, and then got this diagnosis of stroke. And, that seems like it might be a reasonable proxy for who had a stroke. But a proxy is, never exactly what you wanted. And in many cases, that gap ends up being significant. And so this is just one form that measurement bias can take. But I think it's something to really kind of be on the lookout for, because it can be quite subtle. And so now, starting to return to a point that was brought up earlier, aren't people biased? Yes, we are. And so there have been dozens and dozens, if not hundreds, of studies on this, but I'm just going to quote a few, all of which are linked to in this Sandil Mullainathan New York Times article, if you want to find the studies. So this all comes from peer-reviewed research. But when doctors were shown identical files, they were much less likely to recommend a helpful cardiac procedure to Black patients compared to white patients. And so that was same file, but just changing the race of the patient. When bargaining for a used car, Black people were offered initial prices $700 higher and received fewer concessions. Responding to apartment rental ads on Craigslist with a Black name elicited fewer responses than with a white name. An all-white jury was 16 points more likely to convict a Black defendant than a white one, but when a jury had just one Black member, it convicted both at the same rate. And so I share these to show that kind of no matter what type of data you're working on, whether that is medical data or sales data or housing data or criminal justice data, that it's very likely that there's bias in it. There's a question?
No, I was just going to say, I find that last one really interesting, like this kind of idea that a single Black member of a jury, I guess it has some kind of like anchoring impact. It kind of suggests that, I'm sure you're going to talk about diversity later, but I just want to keep this in mind, that maybe like even a tiny bit of diversity here just reminds people that there's a range of different types of people and perspectives.
No, that's a great point. Yeah. And so the question that was kind of asked earlier is, so why does algorithmic bias matter? Like I have just shown you that humans are really biased too. So why are we talking about algorithmic bias? And people have brought this up, kind of like what's the fuss about it? And I think algorithmic bias is very significant and worth talking about. And I'm going to share 4 reasons for that. One is that machine learning can amplify bias. So it's not just encoding existing biases, but in some cases it's making them worse. There have been a few studies on this. One I like is from Maria de Artiga of CMU. And here they took people's, I think, job descriptions from LinkedIn. And what they found is that imbalances ended up being compounded. And so in the group of surgeons, only 14% were women. However, in the true positives, so they were trying to predict the job title from the summary, women were only 11% in the true positives. So this kind of imbalance has gotten worse. And basically there's kind of this asymmetry where the algorithm has learned it's safer for women to kind of not guess surgeon. So this is one reason. Another reason that algorithmic bias is a concern is that algorithms are used very differently than human decision makers in practice. And so people sometimes talk about them as though they are plug and play interchangeable of, if a human's this bias and the algorithm is, this bias, why don't we just substitute it in? However, the whole system around it ends up kind of being different in practice. One kind of aspect of this is people are more likely to assume algorithms are objective or error-free, even if they're given the option of a human override. And so if you give a person, even if you just say, hey, I'm just giving the judge this recommendation, they don't have to follow it. If it's coming from a computer, many people are going to take that as objective. In some cases, also, there may be, pressure from their boss to, not disagree with the computer more times. Nobody's going to get fired by going with the computer recommendation. Algorithms are more likely to be implemented with no appeals process in place. And so we saw that earlier when we were talking about recourse. Algorithms are often used at scale. They can be replicating an identical bias at scale. And algorithmic systems are cheap. And all of these, I think, are interconnected. So in many cases, I think that algorithmic systems are being implemented not because they produce better outcomes for everyone, but because they're kind of a cheaper way to do things at scale. Offering a recourse process is more expensive. Being on the lookout for errors is more expensive. So this is kind of cost-cutting measures. And Kathy O'Neill talks about many of these themes in her book, Weapons of Math Destruction, kind of under the idea that the privileged are processed by people, the poor are processed by algorithms. There's a question?
2 questions.
Mm-hmm.
This seems like an intensely deep topic, needing specialized expertise to avoid getting it wrong. If you were building an ML product, would you approach an academic institution for consultation on this? Do you see a data product development triad becoming maybe a quartet involving an ethics or data privacy expert?
So I think interdisciplinary work is very important. I would definitely focus on trying to find kind of domain experts on whatever your particular domain is, who understand the intricacies of that domain is important. And I think with the academic, it depends. You do want to make sure you get someone who's kind of applied enough to kind of understand how things are happening in industry. But yeah, I think involving more people and people from more fields is a good approach on the whole.
Someone invents and publishes a better ML technique, like attention or transformers, and then next a graduate student demonstrates using it to improve facial recognition by 5%, and then a small startup publishes an app that does better facial recognition, and then a government uses the app to study downtown walking patterns and endangered species, and after these successes for court-ordered monitoring, and then a repressive government then takes that method to identify ethnicities, and then you get a genocide. No one's made a huge ethical error at any incremental step, yet the result is horrific. I have no doubt that Amazon will soon serve up a personally customized price for each item that maximizes their profits. How can such ethical creep be addressed where the effect is remote from many small causes?
So that's a kind of a great summary of how, yeah, these things can happen somewhat incrementally. I'll talk about some tools to implement towards the end of this lesson that hopefully can help us. So some of it is, I think we do need to get better at kind of trying to think a few more steps ahead than we have been. In particular, we've seen examples of people, there was the study of how to identify protesters in a crowd, even when they had scarves or sunglasses or hats on, and when the researchers on that were questioned, they were like, oh, it never even occurred to us that bad guys would use this. We just thought it would be for finding bad people. And so I do think kind of everyone should be building their ability to think a few more steps ahead. And part of this is like, it's great to do this in teams, preferably in diverse teams, can help with that process. On this question of computer vision, there has been, just in the last few months, is it Joe Redman, creator of YOLO, who has said that he's no longer working on computer vision just because he thinks the misuses so far outweigh the positives. And Timnit Gebru said she's considering that as well. So I think there are times where you have to consider. And then I think also really actively thinking about what safeguards do we need to put in place to kind of address the misuses that are happening. Yes?
I just wanted to say somebody really liked the Cathy O'Neill quote, privileged are processed by people, the poor processed by algorithms. And they're looking forward to reading more from Cathy O'Neill. Is that a book that you recommend?
Yes, yeah. And Cathy O'Neill also writes, and Cathy O'Neill is a fellow math PhD, but she also has written a number of good articles. And the book kind of goes through a number of case studies of how algorithms are being used in different places. So kind of in summary of humans are biased. Why do we making a fuss about algorithmic bias? So one, as we saw earlier, machine learning can create feedback loops. So it's not just kind of observing what's happening in the world, but it's also determining outcomes, and it's kind of determining what future data is. Machine learning can amplify bias. Algorithms and humans are used very differently in practice. And then I'll also say technology is power, and with that comes responsibility. And I think for all of us to have access to deep learning, we're still in a kind of very fortunate and small percentage of the world that is able to use this technology right now. And I hope we will all use it responsibly and really take our power seriously. And I just noticed the time, and I think we're about to start next section on analyzing or kind of steps we can take. So this would be a good place to take a break. So let's meet back in 7 minutes at 7:45. All right, let's start back up. And actually, I was at a slightly different place than I thought. But just a few questions that you can ask about projects you're working on, and I hope you will ask about projects you're working on. The first is, should we even be doing this? And considering that maybe there's some work that we shouldn't do. There's a paper when the implication is not to design technology. As engineers, we often tend to respond to problems with, what can I make or build to address this? But sometimes the answer is to not make or build anything. One example of research that I think has huge amount of downside and really no upside I see was kind of to identify the ethnicity, particularly for people of ethnic minorities. And so there was work done identifying the Chinese Uyghurs, which is the Muslim minority in Western China, which has since, over 1 million people have been placed in internment camps. And so I think this is a very harmful line of research. I think that there have been at least 2 attempts of building a classifier to try to identify someone's sexuality, which is it's probably just picking up on kind of stylistic differences, but this is something that could also be quite dangerous, as in many countries it's illegal to be gay. Yes.
So this is a question from me, which I don't know the answer to.
Yeah.
As that title says, a Stanford scientist says he built the gaydar using the lamest AI possible to prove a point. And my understanding is that point was to say I guess it's something like, hey, you could use Fast AI Lesson 1 after an hour or two. You can build this thing. Anybody can do it. How do you feel about this idea that there's a role to demonstrate what's readily available with the technology we have?
Yeah, I mean, that's something that I think, so I appreciate that, and I'll talk about this a little bit later, OpenAI with GPT-2, I think was trying to raise a debate around dual use and what is responsible release of dual use technology, and what's a kind of responsible way to raise awareness of what is possible. In the cases of researchers that have done this on the sexuality question, to me, it hasn't seemed like they've put adequate thought into how they're conducting that and who they're collaborating with to ensure that it is something that is leading to kind of helping address the problem. But I think you're right that I think there is probably some place for letting people, know what is probably widely available now.
Yeah, it reminds me a bit of like pen testing in InfoSec, where it's kind of considered, well, there's an ethical way that you can go about pointing out that it's trivially easy to break into somebody's system.
Yes, yeah, I would agree with that there is an ethical way, but I think that's something that we as a community still have more work to do in even determining what that is. Other questions to consider are what bias is in the data, and something I should highlight is people often ask me, how can I debias my data or ensure that it's bias free? And that's not possible. All data contains bias, and the kind of most important thing is just to understand kind of how your data set was created and what its limitations are, so that you're not blindsided by that bias, but you're never going to fully remove it. And some of the, I think, most promising approaches in this area are work like Timnit Gebru's data sheets for data sets, which is kind of going through and asking kind of a bunch of questions about how your data set was created and for what purposes and how it's being maintained, and what are the risks in that, just to really kind of be aware of the context of your data. Can the code and data be audited? I think particularly in the United States, we have a lot of issues with when private companies are creating software that's really impacting people through the criminal justice system or hiring. And when these things are, kind of their proprietary black boxes that are protected in court, this creates a lot of kind of issues of, what are our rights around that. Looking at error rates for different subgroups is really important, and that's what's so powerful about Joy Balamwini's work. If she had just looked at light skin versus dark skin and men versus women, she wouldn't have identified just how poorly the algorithms were doing on dark-skinned women. What is the accuracy of a simple rule-based alternative? And this is something I think Jeremy talked about last week, which is just kind of good machine learning practice to have a baseline. But particularly in cases like the COMPAS recidivism, where this 130 variable black box is not doing much better than a linear classifier on 3 variables, that raises kind of a question of why are we using this? And then what processes are in place to handle appeals or mistakes? Because there will be errors in the data, there may be bugs in the implementation, and we need to have a process for recourse. Yes?
Can you this is for me now? Sorry, I'm asking my own questions. Nobody voted them up at all. What's the thinking behind this idea that a simpler model are you kind of saying a simpler model, all the other things being the same, you should pick the simpler one? Is that what this baseline's for? And if so, what's the kind of thinking behind that?
Well, okay, so I guess with the COMPAS recidivism algorithm, some of this for me is linked to the proprietary black box nature. And so you're right, if we had a way to introspect and what were our rights around appealing something. But I would say, like, why use the more complex thing if the simpler one works the same? And then how diverse is the team that built it? And I'll talk more about team diversity later in this lesson.
It says Jeremy at the start, but I'm not the teacher. So it actually says, Jeremy, do you think transfer learning makes this tougher, auditing the data that led to the initial model? I assume they mean, Jeremy, please ask Rachel.
No, they were asking you. That's a good question. Again, I think it's important. I would say I think it's important to have information probably on both data sets, what the initial data set used was, and what the data set you used to fine tune it. Do you have thoughts on that?
What she said.
And then I'll say, so while bias and fairness, as well as accountability and transparency, are important, they aren't everything. And so there's this great paper, A Mulching Proposal, by Oz Keys et al. And here they talk about a system for turning the elderly into high nutrient slurry. So this is something that's clearly unethical, but they propose a way to do it that is fair and accountable and transparent and meets these qualifications. And so that kind of shows some of the limitations of this framework, as well as kind of being a good technique for kind of inspecting whatever framework you are using, of trying to find something that's clearly unethical that could meet the standards you've put forth.
That technique, I really like it. It's my favorite technique from philosophy. It's this idea that you say, okay, given this premise, here's what it implies, and then you try and find an implied result which intuitively is clearly insane. And it's the number one philosophical thinking tool I got out of university, and sometimes you can have a lot of fun with it, like this time too.
Cool, thank you. All right, so the next kind of big case study or topic I want to discuss is disinformation. So in 2016, in Houston, a group called Heart of Texas posted about a protest outside an Islamic center. They told people to come armed. Another Facebook group posted about a counter protest to show up supporting freedom of religion and inclusivity. And so there were kind of a lot of people present at this, more people on the side supporting freedom of religion. And a reporter, though, for the Houston Chronicle noticed something odd, which he was not able to get in touch with the organizers for either side. And it came out many months later that both sides had been organized by Russian trolls. And so this is something where you had the people protesting were, genuine Americans kind of protesting their beliefs, but they were doing it in this way that had been kind of completely framed very disingenuously by Russian operatives. And so when thinking about disinformation, it is not, people often think about so-called fake news, and inspecting like a single post, is this true or false? But really disinformation is often about orchestrated campaigns of manipulation, and that it involves can involve seeds of truth. Kind of the best propaganda always involves kernels of truth, at least. It also involves kind of misleading context, and can involve very kind of sincere people that get swept up in it. A report came out this fall, an investigation from Stanford's Internet Observatory, where Renee DiResta and Alex Stamos work, of Russia's kind of most recent disinformation, or most recently identified disinformation campaign. And it was operating in 6 different countries in Africa. It often purported to be local news sources. It was multi-platform. They were encouraging people to join their WhatsApp and Telegram groups, and they were hiring local people as reporters. And a lot of the content was not necessarily disinformation. It was stuff on culture and sports and local weather. There was a lot of kind of very pro-Russia coverage, but that it covered a range of topics. And so this is kind of a very sophisticated phase of disinformation. And in many cases, it was hiring locals kind of as reporters to work for these sites. And I should say, well, I've just given 2 examples of Russia. Russia certainly does not have a monopoly on disinformation. There are plenty of people involved in producing it. Kind of topical issue, there's been a lot of disinformation around coronavirus and COVID-19. In terms of kind of a personal level, if you're looking for advice on spotting disinformation or to share with loved ones about this, Mike Caulfield is a great person to follow. And he's even, so he tweets at Holden, and then he has started an infodemic blog specifically about COVID-19. But he talks about his approach and how people have been trained in schools for 12 years. Here's a text, read it, use your critical thinking skills to figure out what you think about it. But professional fact checkers do the opposite. They get to a page and they immediately get off of it and look for kind of higher quality sources to see if they can find confirmation. Caulfield also really promotes the idea of a lot of critical thinking techniques that have been taught take a long time, and we're not going to spend 30 minutes evaluating each tweet that we see in our Twitter stream. It's better to give people an approach that they can do in 30 seconds. That it's not going to be fail proof if you're just doing something for 30 seconds, but it's better to check than to have something that takes 30 minutes that you're just not going to do at all. So I wanted to kind of put this out there as a resource. And he has a whole kind of set of lessons at lessons.checkplease.cc. And he's a professor. And I, in the data ethics course I'm teaching right now, I made my first lesson, the first half of which is kind of specifically about coronavirus disinformation. I've made that available on YouTube. I've already shared it, and so I'll add a link on the forums if you want a lot more detail on disinformation than just kind of this short bit here. But so going back to kind of like what is disinformation, it's important to think of it as an ecosystem. Again, it's not just a single post or a single news story that has is misleading or has false elements in it, but it's really this broader ecosystem. Claire Wardle, First Draft News, who is a leading expert on this and does a lot around kind of training journalists and how journalists can report responsibly, talks about the trumpet of amplification. And this is where rumors or memes or things can start on 4chan and 8chan and then move to closed messaging groups such as WhatsApp, Telegram, Facebook Messenger, from there to conspiracy communities on Reddit or YouTube, then to kind of more mainstream social media, and then picked up by the professional media and politicians. And so this can make it very hard to address that it is this kind of multi-platform. In many cases, campaigns may be utilizing kind of the differing rules or loopholes between the different platforms. And I think we've certainly are seeing more and more examples where it doesn't have to go through all these steps, but can jump forward. And online discussion is very, very significant because people, it helps us form our opinions. And this is tough because I think most of us think of ourselves as pretty independent minded, but discussion really does, we evolved as kind of social beings and to be influenced by people in our in-group and in opposition to people in our out-group. And so online discussion impacts us. People discuss all sorts of things online. Here's a Reddit discussion about whether the US should cut defense spending. You have comments, you're wrong. The defense budget is a good example of how badly the US spends money on the military. Someone else says, yeah, but that's already happening. There's a huge increase in the military budget. The Pentagon budget's already increasing. I didn't mean to sound like stop paying for the military. I'm not saying that we cannot pay the bills, but I think it would make sense to cut defense spending. Does anyone want to guess what subreddit this is from? Oh.
Unpopular opinion, news, change my view, net neutrality.
Okay. Those are good guesses, but they're wrong.
I love the way you say no.
This is all from, well, it's from the sub-simulator GPT-2. So these comments were all written by GPT-2. And this is in good fun. It was clearly labeled on the subreddit that it's coming, and GPT-2 is a language model from OpenAI that was kind of in a trajectory of research that many groups were on. And so it was released, I guess, about a year ago. And Should I read the unicorn story, Jeremy? Okay, so if many of you have probably seen this, so here, and this was cherry picked, but this is still very, very impressive. So a human written prompt was given to the language model. In a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. And then the next part is all generated by the language model. So this is a deep learning model that produced this, and the computer model generated Dr. Jorge Perez at what appeared to be a natural fountain surrounded by 2 peaks of rock and silver snow. Perez and the others then ventured further into the valley. By the time we reached the top of one peak, the water looked blue, with some crystals on top, said Perez. Perez and his friends were astonished to see the unicorn herd. These creatures could be seen from the air without having to move too much to see them. They were so close they could touch their horns. While examining these bizarre creatures, the scientists discovered that the creatures also spoke some fairly regular English. Perez stated, "We can see, for example, that they have a common language, something like a dialect or dialectic." And so I think this is really compelling prose to have been generated by a computer in this form. So we've also seen advances in computers generating pictures, specifically GANs. So Katie Jones was listed on LinkedIn as a Russia and Eurasia Fellow. She was connected to several people from mainstream Washington think tanks, and the Associated Press discovered that she is not a real person. This photo was generated by a GAN. And so this, I think, gets kind of scary when we start thinking about how compelling the text that's being generated is, and combining that with pictures. These photos are all from thispersondoesnotexist.com, generated by GANs. And there's a very real and imminent risk that online discussion will be swamped with fake manipulative agents. To an even greater extent than it already has, and that this can be used to influence public opinion. So, actually, I guess. Well, no, I'll keep going. Going back in time to 2017, the FCC was considering repealing net neutrality, and so they opened up for comments to see, how do Americans feel about net neutrality. And this is a sample of many of the comments that were opposed to net neutrality. They wanted to repeal it. And it included, I'll just read a few clips. Americans, as opposed to Washington bureaucrats, deserve to enjoy the services they desire. Individual citizens, as opposed to Washington bureaucrats, should be able to select whichever services they desire. People like me, as opposed to so-called experts, should be free to buy whatever products they choose. And these have been helpfully color-coded, so you can kind of see a pattern that this was a bit of a Mad Libs, where you had a few choices for green for the first noun, and then in orange or red, I guess it's as opposed to or rather than. Orange, we've got either Washington bureaucrats, so-called experts, the FCC, and so on. And this analysis was done by Jeff Cow, who's now a computational journalist at ProPublica, doing great work. And he did this analysis, discovering this campaign in which these comments were designed to look unique, but had been created kind of through some mail merge style, kind of putting together a Mad Libs. Yes? So this was great work by Jeff. He found that while they received the FCC received over 22 million comments, less than 4% of them were truly unique. And this is not all malicious activity. There are many kind of ways where you get a template to contact your legislator about something, but in the example kind of shown previously, these were designed to look like they were unique when they weren't. And more than 99% of the truly unique comments wanted to keep net neutrality. However, that was not the case if you looked at the full 22 million comments. However, this was in 2017, which may not sound that long ago, but in in the field of natural language processing, we've had like an entire kind of revolution since then. There's just been so much progress made. And this would be, I think, virtually impossible to catch today, using if someone was using a sophisticated language model to generate comments.
So Jess asks a question, which I'm going to treat it as a two-part question, even if
Okay.
it's not necessarily. What happens when there's so much AI trolling that most of what gets scraped from the web is AI-generated text? And then the second part, and then what happens when you use that to generate more AI-generated text?
Yeah, so for the first part, this is a real risk, or not risk, but kind of challenge we're facing of real humans can get drowned out when so much text is going to be AI trolling, and we're already seeing. And in the interest of time, I can talk about disinformation for hours, and I had to cut a lot of stuff out. But many people have talked about how kind of the new form of censorship is about drowning people out. And so it's not necessarily kind of forbidding someone from saying something, but just totally just drowning them out with a massive quantity of text and information and comments, and AI can really facilitate that. And so I do not have a good solution to that. In terms of AI learning from AI text, I think you're going to get systems that are potentially kind of less and less relevant to humans and may have harmful effects if they're kind of being used to create software that is interacting with or impacting humans. So that's a concern.
I mean, one of the things I find fascinating about this is we could get to a point where 99.99% of tweets and fast AI forum posts and whatever are auto-generated, particularly on kind of more like political type places where a lot of it's pretty low content, pretty basic. And the thing is, like, if it was actually good, you wouldn't even know. So what if I told you that 75% of the people you're talking to on the forum right now are actually bots? How can you tell which ones they are? How would you prove whether I'm right or wrong?
Yeah, no, and I think this is a real issue on Twitter of, particularly people you don't know, of, wondering, like, is this an actual person or a bot? I think is a common question people wonder about, and can be hard to tell. But I think it has significance for, has a lot of significance for kind of how human government works. I think there's something about humans being in society and having norms and rules and mechanisms that this can really undermine and make difficult. And so when GPT-2 came out, Jeremy Howard, co-founder of FastAI, was quoted in the Verge article on it. I've been trying to warn people about this for a while. We have the technology to totally fill Twitter, email, and the web up with reasonable sounding, context-appropriate prose, which would drown out all other speech and be impossible to filter. So one kind of step towards addressing this is the need for digital signatures. Oren Etziani, the head of the Allen Institute on AI, wrote about this in HBR. He wrote, recent developments in AI point to an age where forgery of documents, pictures, audio recordings, videos, and online identities will occur with unprecedented ease. AI is poised to make high-fidelity forgery inexpensive and automated, leading to potentially disastrous consequences for democracy, security, and society, and proposes kind of digital signatures as a means for authentication. And I will say here, kind of one of the additional risk of kind of all this forgery and fakes is that it also undermines people speaking the truth. And Zeynep Tufekci, who does a lot of research on protests around the world and different social movements, has said that she's often approached by kind of whistleblowers and dissidents who, in many cases, will risk their lives to try to publicize like a wrongdoing or human rights violation, only to have kind of bad actors say, oh, that picture was photoshopped, that was faked, and that it's kind of now this big issue for whistleblowers and dissidents of how can they verify what they are saying, and that kind of that need for verification. And then someone you should definitely be following on this topic is Renee DiResta. And she wrote a great article with Mike Godwin last year, framing that we really need to think disinformation as a cybersecurity problem. It's these kind of coordinated campaigns of manipulation and bad actors. And there's, I think, some important work happening at Stanford as well on this. All right, questions on disinformation? Okay, so next step, ethical foundations. So the fast AI approach, we always like to kind of ground everything in what are the real world case studies before we get to kind of the theory underpinning it. And I'm not going to go too deep on this at all. So there's a fun article, What Would an Avenger Do? And hat tip to Casey Fiesler for suggesting this. And it goes through kind of three common ethical philosophies, utilitarianism, and gives the example of Iron Man, trying to maximize good, deontological ethics of Captain America being an example of this, adhering to the right, and then virtue ethics, Thor, living by a code of honor. And so I thought that was a nice reading. Yes?
Where do you stand on the argument that social media companies are just neutral platforms and that problematic content is the entire responsibility of the users, just the same way that phone companies aren't held responsible when phones are used for scams, or car companies held responsible when vehicles are used for, say, terrorist attacks?
So I do not think that that the platforms are neutral, because they make a number of design decisions and enforcement decisions around even kind of what their terms of service are and how those are enforced, and that in keeping in mind harassment can drive many people off of platforms, and so many of those decisions, it's not that everybody gets to keep free speech when there's no enforcement. It's just changing kind of who is silenced. I do think that there are a lot of really difficult questions that are raised about this, because I think that the platforms, they are not publishers, but they are in this, I think, kind of intermediate area where they're performing many of the functions that publishers used to perform. So, like a newspaper, which is curating which articles are in it, which is not what platforms are doing, but they are getting closer to that. Something I come back to is it is an uncomfortable amount of power for private companies to have. And so it does raise a lot of difficult decisions, but I do not believe that they are neutral. So for this part, I mentioned the Markula Center earlier. Definitely check out their site, Ethics and Technology Practice. They have a lot of useful resources. And I'm going to go through these relatively quickly as just kind of examples. So they give some kind of deontological questions that technologists could ask. And so deontological ethics are where you kind of have various kind of rights or duties that you might want to respect. And this can include principles like privacy or autonomy. How might the dignity and autonomy of each stakeholder be impacted by this project? What considerations of trust and of justice are relevant? Does this project involve any conflicting moral duties to others? In some cases, there'll be kind of conflict between different rights or duties you're considering. And so this is kind of an example, and they have more in the reading of the types of questions you could be asking, kind of when evaluating, of just even how do you evaluate kind of whether a project is ethical. Consequentialist questions: who will be directly affected? Who will be indirectly affected? And consequentialist includes utilitarianism as well as common good. Will the effects in aggregate create more good than harm? And what types of good and harm? Are you thinking about all the relevant types of harm and benefit, including psychological, political, environmental, moral, cognitive, emotional, institutional, cultural? Also looking at long-term benefits and harms. And then who experiences them? Is this something where the risk of the harm are going to fall disproportionately on the least powerful? Who's going to be the ones to accrue the benefits? Have you considered dual use? And so these are again kind of questions you could use when trying to evaluate a project. And I think, and the recommendation of the Markula Center is that this is a great activity to be doing as a team and as a group. Yes.
I was going to say, like, I can't overstate how useful this tool is. Like, you might think, oh, it's just a list of questions, yeah, But like, this is kind of, to me, this is the big gun tool for how you handle this. Is like, if somebody's helping you think about the right set of questions, and then you like go through them with a diverse group of people and discuss the questions. I mean, this is gold. Like, don't go back and reread these, and don't just skip over them, because take them to work, use them next time you're talking about a project. They're a really great set of questions to use, a great tool in your toolbox.
Yeah, and go to the original reading has even kind of more detail and more elaboration on the questions. And then they kind of give a summary of 5 potential ethical lenses. The rights approach, which option best respects the rights of all who have a stake. The justice approach, which option treats people equally or proportionally. And so these two are both deontological. The utilitarian approach, which option will produce the most good and do the least harm. The common good approach, which option best serves the community as a whole, not just the members. And so here 3 and 4 are both consequentialist. And then virtue approach, which option leads me to act as the sort of person I want to be. And that can involve, particular virtues of, do you value trustworthiness or truth or courage? And so, a great activity, if this is something that you're studying or talking about at work with your teammates, the Markula Center has a number of case studies that you can talk through, and we'll even ask you to kind of evaluate them through these 5 lenses, and how does that kind of impact your take on what the right thing to do is.
It's kind of weird for a programmer, a computer programmer, or data scientist in some ways to like think of these as tools like Fast AI or Pandas or whatever, but I mean, they absolutely are. These are like software tools for your brain, to help you kind of go through a program that might help you debug your thinking.
Great, thank you. And then as someone brought up earlier, so that was a kind of very Western-centric intro to ethical philosophy. There are other ethical lenses in other cultures, and I've been doing some reading, particularly on the Maori worldview. I don't feel confident enough in my understanding that I could represent it, but it is very good to be mindful that, there are other ethical lenses out there, and I do very much think that the people being impacted by a technology, like their ethical lens is kind of what matters, and that this is a particular issue when we have so many kind of multinational corporations. And there's an interesting project going on in New Zealand now, where the New Zealand government is kind of considering its AI approach, and is at least ostensibly kind of wanting to include the Maori view on that. So that's kind of a little bit of theory, but now I want to talk about some kind of practices you can implement in the workplace Again, this is from the Markula Center. So this is their ethics toolkit, which I particularly like. And I'm not going to go through all of them. I'm just going to tell you a few of my favorites. So tool 1 is ethical risk sweeping. And this, I think, is similar to the idea of kind of pen testing that Jeremy mentioned earlier from security, but to have regularly scheduled ethical risk sweeps. And while no vulnerabilities found is generally good news, that doesn't mean that it was a wasted effort, and you keep doing it. Keep looking for ethical risk. One moment. And then assume that you missed some risk in the initial project development. Also, you have to set up the incentives properly where you're rewarding team members for spotting new ethical risk. All right.
Yeah, so I've got some comments here. So my comment here is about the learning rate finder, and I'm not going to bother with the exact mathematical definition, partly because I'm a terrible mathematician and partly because it doesn't matter. But if you just remember, oh, sorry, that's actually not me. I am just reading something that Patty Hendricks has trained a language model of me. So that was me reading the language model of me.
That was great.
It wasn't the real me.
Cool, thank you. So this is a tool 1. I would say another kind of example of this, I think, is like red teaming, of having a team within your org that's kind of trying to find your vulnerabilities. Tool 3, another one I really like, expanding the ethical circle. So whose interests, desires, skills, experiences, and values have we just assumed rather than actually consulted? Who are all the stakeholders who will be directly affected? And have we actually asked them what their interests are? Who might use this product that we didn't expect to use it, or for purposes that we didn't initially intend? And so then a great implementation of this comes from the University of Washington's Tech Policy Lab. Did a project called Diverse Voices, and it's neat. They have both a academic paper on it, and then they also kind of have like a lengthy guide on how you would implement this. But the idea is how to kind of organize expert panels around new technology. And so they did a few samples. One was they're considering augmented reality, and they held expert panels with people with disabilities, people who are formerly or currently incarcerated, and with women to get their input and make sure that that was included. They did a second one on an autonomous vehicle strategy document, and organized expert panels with youth, with people that don't drive cars, and with extremely low income people. And so I think this is a great guide if you're kind of unsure of how do you even go about setting something like this up to expand your circle, include more people, and get perspectives that may be underrepresented by your employees. So I just want to let you know that this resource is out there. Tool 6 is think about the terrible people. And this can be hard because I think we're often, thinking kind of positively, or thinking about people like ourselves who don't have terrible intentions, but really think about who might want to abuse, steal, misinterpret, hack, destroy, or weaponize what we build. Who will use it with alarming stupidity or irrationality? What rewards, incentives, openings has our design inadvertently created for those people? And so kind of remembering back to the section on metrics, how are people going to be trying to game or manipulate this? And how can we then remove those rewards or incentives? And so this is an important important step to take. And then tool 7 is closing the loop, ethical feedback and iteration, remembering this is never a finished task, and identifying feedback channels that will give you kind of reliable data, and integrating this process with quality management and user support, and developing formal procedures and chains of responsibility for ethical iteration. And this tool reminded me of a blog post by Alex Fierce that I really like. Alex Fierce was previously the chief legal officer at Medium, and I guess this was a year ago. He interviewed, it was something like 15 or 20 people that have worked in trust and safety. And trust and safety includes content moderation, although it's not solely content moderation. And kind of one of the ideas that came up that I really liked was one of the people, and so many of these people have worked in trust and safety for years at big name companies. And one of them said, the separation of product people and trust people worries me, because in a world where product managers and engineers and visionaries cared about this stuff, it would be baked into how things get built. If things stay this way, that product and engineering are Mozart and everyone else is Alfred the Butler, the big stuff is not going to change. And so I think at least two people in this kind of talk about this idea of needing to better integrate trust and safety, which are often kind of on the front lines of seeing abuse and misuse of a technology product, integrating that more closely with product and eng, so that it can kind of be more directly incorporated, and you can have a tighter feedback loop there about what's going wrong and how that could be designed against. Okay, so these were I linked to a few blog posts and research I thought relevant, but inspired by the Markkula Center's tools for tech ethics, and hopefully those are practices you could think about potentially implementing at your company. So next I want to get into diversity, which I know came up earlier. Only 12% of machine learning researchers are women. So this is kind of a very dire statistic. There's also a kind of extreme lack of racial diversity and age diversity, and other factors. And this is significant. A kind of positive example of what diversity can help with, in a post, Tracy Chow, who was an early engineer at Quora and later at Pinterest, wrote that the first feature, and so I think she was like one of the first 5 employees at Quora, the first feature I built when I worked at Quora was the block button. I was eager to work on the feature because I personally felt antagonized and abused on the site. And she goes on to say that if she hadn't been there, they might not have added the block button as soon. And so that's kind of like a direct example of how having a diverse team can help. So my kind of key advice for anyone wanting to increase diversity is to start at the opposite end of the pipeline from where people talk about the workplace. I wrote a blog post 5 years ago, "If you think women in tech is just a pipeline problem, you haven't been paying attention." And this was the most popular thing I had ever written until Jeremy and I wrote the COVID-19 post last month. But so the kind of second most popular thing I've written. But I linked to a ton of research in there. A key statistic to understand is that 41% of women working in tech end up leaving the field compared to 17% of men. And so this is something that recruiting more girls into coding or tech is not going to address this problem if they keep leaving at very high rates.
I just had a little peek at the YouTube chat, and I see people are asking questions there. I just wanted to remind people that we are not, that Rachel and I do not look at that. If you want to ask us questions, you should use the forum thread. And if you see questions that you like, then please vote them up, such as this one. How about an ethical issue bounty program, just like the bug bounty programs that some companies have?
No, I think that's a neat idea. Yeah, of rewarding people for finding ethical issues. And so the reason that women are more likely to leave tech is, and this was found in a meta-analysis of over 200 books, white papers, articles. Women leave the tech industry because they're treated unfairly, underpaid, less likely to be fast-tracked than their male colleagues, and unable to advance. And too often diversity efforts end up just focusing on white women, which is wrong. Interviews with 60 women of color who work in STEM research found that 100% had experienced discrimination, and their particular stereotypes varied by race. And so I would say it's very important to focus on women of color in diversity efforts as a kind of the top priority. A study found that men's voices are perceived as more persuasive, fact-based, and logical than women's voices, even when reading identical scripts. Researchers found that women receive more vague feedback and personality criticism in performance evaluations, whereas men are more likely to receive actionable advice tied to concrete business outcomes. When women receive mentorship, it's often advice on how they should change and gain more self-knowledge. When men receive mentorship, it's public endorsement of their authority. Only one of these has been statistically linked to getting promoted. It's the public endorsement of authority. And all these studies are linked to in another post I wrote called The Real Reason Women Quit Tech and How to Address It. Is that a question, Jeremy? Or yeah, so if you're interested, kind of these two blog posts, I link to a ton of relevant research on this. And I think this is kind of the workplace is the place to start in addressing these things. So another issue is tech interviews are terrible for everyone. So now kind of working one step back from people that are already in your workplace, but thinking about the interview process. And I wrote a post on how to make tech interviews a little less awful and went through a ton of research. And I will say that the interview problem, I think, is a hard one. I think it's very time consuming and hard to interview people well. But kind of the two most interesting pieces of research I came across, one was from TripleByte, which is a recruiting company that interviews kind of does this first round technical interview for people. And then they interview at Y Combinator. It's a Y Combinator company. And then they interview at Y Combinator companies. And so they have this very interesting data set where they've kind of given everybody the same technical interview. And then they can see which companies people got offers from when they were, interviewing at many of the same companies. And the number one finding from their research is that the types of programmers that each company looks for often have little to do with what the company needs or does. Rather, they reflect company culture and the backgrounds of the founders. And this is something where they even gave the advice of if you're job hunting, try to look for companies where the founders have a similar background to you. And that's something that while that makes sense, that's going to be much easier for certain people to do than others, and particularly given the gender and racial disparities in VC funding, that's going to make a big difference. Yes?
Actually, I would say that was the most common advice I heard from VCs when I became a founder in the Bay Area, was when recruiting, focus on getting people from your network and people that are as like-minded and similar as possible. That was by far the most common advice that I heard.
Yeah, this is maybe like one of my controversial opinions. I do feel like ultimately, I get why people hire from their network. And I think that long term, we all need to be particularly white people need to be developing more diverse networks. And that's like a, 10-year project. That's not something you can do right when you're hiring, but really kind of developing a diverse network of friends and trusted acquaintances kind of over time. But yeah, thank you for that perspective too, Jeremy. Then kind of the other study I found really interesting was one where they gave people resumes, and in one case, so one resume had more academic qualifications, and then one had more practical experience, and then they switched the gender. One was a woman, one was a man, or male name, a female name. And basically people were more likely to hire the male, and then they would use a post hoc justification of, I chose him because he had more academic experience, or I chose him because he had more practical experience. And that's something that I think it's very human to use post hoc justifications, but it's a real risk that definitely shows up in hiring.
Ultimately, AI or any other technology are developed or implemented by companies for financial advantage, i.e. more profit. Maybe the best way to incentivize ethical behavior is to tie financial or reputational risk to good behavior. In some ways, similar to how companies are now investing in cybersecurity because they don't want to be the next Equifax. Can grassroots campaigns help in better ethical behavior with regards to their use of AI?
That's a good question. Yeah, and I think there are a lot of analogies with cybersecurity, and I know that for a long time, I think it was hard for people to make, or people had trouble making the case to their bosses of why they should be investing in cybersecurity, particularly because cybersecurity is, something like when it's working well, you don't notice it. So that can be hard to build the case. So I think that there is a place for grassroots campaigns. and I'm going to talk more. I'm going to talk about policy in a bit. It can be hard in some of these cases where there are not necessarily meaningful alternatives. So I do think like monopolies can kind of make that harder. That's it. Yeah, a good question. All right. So next step, actually on this slide, is the need for policy. And so I'm going to start with a case study of what's one thing that gets companies to take action. And so, as I mentioned earlier, an investigator for the UN found that Facebook played a determining role in the Rohingya genocide. I think the best article I've read on this was by Timothy McLaughlin, who did a super in-depth dive on Facebook's role in Myanmar, and people warned Facebook executives in 2013 and in 2014 and in 2015 how the platform was being used to spread hate speech and to incite violence. One person in 2015 even told Facebook executives that Facebook could play the same role in Myanmar that the radio broadcast played during the Rwandan genocide. And radio broadcast played a very terrible and kind of pivotal role in the Rwandan genocide. Somebody close to it said, that's not 2020 hindsight. The scale of this problem was significant and it was already apparent. And despite this, in 2015, I believe Facebook only had 4 contractors who even spoke Burmese, the language of Myanmar. Question?
That's an interesting one. How do you think about our opportunity to correct biases in artificial systems versus the behaviors we see in humans? For example, a sentencing algorithm can be monitored and adjusted versus a specific biased judge who remains in their role for a long time.
Theoretically, though, I think I feel a bit hesitant